Well, hello and welcome to this exercise on numbers and combinations. It is an IGCSE past exam paper, and I think it's Cambridge, suggested to me by one of my subscribers, and he wants an explanation on how the answers were obtained. So here we go, and he says, how many even numbers less than 500, even numbers and less than 500 can be formed using the digits 1, 2, 3, 4, 5. Now, each digit may be used only once in any given number, so we cannot have 112 or 314 or even 441. Okay, now that's the first one. The second question says, a committee of 8 people is to be chosen from 7 men and 5 women. Find the number of different committees that could be selected if, so there's a condition there attached, if the committee contains at least 3 men and at least 3 women. Part 2 says the oldest man, or, now this is important there, the oldest man or the oldest woman, but not both, must be included in the committee. Okay, now for the first one, I've done this by investigation, or if you like, heuristically. So doing this way means that if you're doing IGCSE or GCSE, you should be able to do this as well. Okay, now to do that, I've relied on our old friend, the tree diagram. So firstly, the two numbers we can form will be the numbers 2 and 4. So the first two even numbers we can form will be 2 and 4. Okay, so and this is units and tens and hundreds here. Right, so if I go down the 2 digits root, so everything has got to end in 2, right? If I go down that root, so I can have my 2. I can also have 10 plus 2, and I get 12. And I can do 3 plus 2, and I get 32. And I can do 4 plus 2, and I get 42. And I do 5 plus 2, and I get 52. You see that there? Right. I can also do 300 plus 10 plus 2, and that gives me 312. Okay, so I can do 400 plus 10 plus 2, 412. I could do 100 plus 30 plus 2, 132. I could do 400 plus 30 plus 2, 432. I could do 100 plus 40 plus 2, 142. I can do 300 plus 40 plus 2, that will give you 342. I can do 100 plus 50 plus 2, 152. I can do 300 plus 50 plus 2, 352, and I get 400 plus 50 plus 2, that's 452. Okay. Now, note here that there is no 5 in the 100 row, because that gives us a number greater than 500. So that's no good. So you can have 5 there. Okay. So we now have one number, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we've got 14 numbers. And don't forget that the 4s and the 2s are interchangeable. So I can do the same thing, exercise, using going down the digit 4 root there. So in effect, the answer we get will be 14 plus 14 as equal to 28. So we can form 28 numbers using the digits 1, 2, 3, 4, 5 and numbers below 500. So the answer we require is 28. Okay, now for B, we are supposed to form a committee of 8 people from 7 men and 5 women, and the conditions are that at least 3 men and at least 3 women. that number there is important. Oh, sorry, that number, the word "and" there is very important. Okay, so now you can choose 3 men from 7 and 5 women from 5, and the number of ways you can do that will be 35, because you got this "and" there, we've got this "and" that suggests that there must be, or there should be, multiplication somewhere. That's what we got there. If you remember our exercises on probability, similar to that. So go 35. We can also choose 4 men from 7 men and 4 women from 5 men, and that will give us 8 members in the committee. So this is arithmetic, and there are 175 ways you can choose 4 men from 7 and 4 women from 5. Okay. Similarly, we can do the same exercise from choosing 5 men from 7 and 3 women from 5. Again, the answer we get is 210 there. Don't forget that 5 plus 3 will give us 8. So that satisfies the conditions laid down in the question itself. So now, in total, we have 35 plus 175 plus 210 there. So we can have, and the total we got for that is 420. So that's the answer, 420. Now, for this one, right, now to start with, the oldest man and the oldest woman have been ruled out from our choices to start with, so they're no longer there. So this will now reduce the number of men available to be chosen to 6, and the number of women available to be chosen to 4. So the whole dynamics has now changed. So we now have this here. We have to choose from 6 men and 4 women there. Okay? Because it's imperative that either the oldest man or the oldest woman has got to be chosen. So we know that already. So that there should be no, that we've got no choice in the matter at all. So now what we do is we can choose 6 men from 6 men and 1 woman from 4 women. So 6 plus 1 will give us 7. And then we can add either the man or the oldest woman there. Okay. Moving on, we can also choose 5 men from 6 men and 2 women from 4 women. So we've got 5 plus 2 give us 7, and the number of ways we can do that is 36. Or we can choose 4 men from 6 men and 3 women from 4 women, and we can do that in 60 ways. Okay. And lastly, we can choose 3 men from 6 men and 4 women from 4 women, and the answer to that is 20. Now, suppose that we've made up our mind that we're going to choose a lady. So this calculation is based on choosing the lady to start with. So if we say the old lady, and there are 120 ways in which we can form a committee of 7 plus the old lady, that make it 8. So if you add all that, you get 120. Okay. Now, suppose we said to ourselves, well, we're not going to choose the old lady, but we're going to choose the old man. Okay. So this calculation will be based on choosing the old gentleman there. So if we call that OM, yeah, as the old man. Oops, sorry, as the old man there, and sorry, old man. And again, the number of ways we can choose a committee will be 120 there. Now, don't forget that in the calculation, in the question, it says the oldest man or the oldest woman, which implies that we have to add these two, because the word "or" suggests addition. If you remember in our topics on probability, so that means you have to add these two. So now the answer will require the number of ways we can choose a committee of 8. We can choose a committee of 7 plus either the oldest man or the oldest woman will be 120 plus 120, and the answer we get is 240. And I hope all that made some sense, and please subscribe. Thank you for watching, and bye bye now. Bye bye.